Okay, so today we're going to talk about 4 different postulates and theorems that we can use to prove that triangles are congruent without having to say that all 3 angles and all 3 sides are congruent. So if these are true, then the 2 triangles are congruent. So if 3 sides of one triangle are congruent to the 3 sides of the other, so they're all the same lengths, those 2 triangles are congruent. That's pretty straightforward. Okay, I'm going to draw a picture for these next couple. If 2 sides of the included, and then the angle in between those 2 sides are congruent on 2 triangles, then that means the 2 triangles are congruent. So what that means is like a side, an angle, and a side. So it would have to be like this side here, this angle, and this side. So the angle formed by those 2 sides. It has to be in that order. It can't be an angle over here. Okay? That means that the 2 triangles are congruent. Angle side angle postulate, which is kind of the same idea, so I'm only going to draw part of this triangle. So if the 2 angles are here and this side is the same, and you're told on 2 triangles it has 2 same angles and the side in between those 2 angles, then those 2 triangles are congruent. And then angle, angle, side. And okay, so again, order matters here. So it has to be the angle and then another angle and then the next side. So it has to be like angle, angle, and then the next side. If you ever skip over an angle and skip over a side, none of these theorems or postulates will work. And so we will practice and look at what that means. But these are all included on the notes that I have for this section. Okay, so let's say there's a triangle VGB. So that means we're just going to label this triangle V, G, and B. Okay. We want to talk about, just given that information, we can say which sides include angle B, and that's side BB and side BG, because those are the 2 sides that form angle B right here. Okay? So again, we can draw this triangle STN, and it says which angle is included between NS, so this side, and TN, so that would be angle N, because that is the side of the angle that is formed by those 2 sides. And we can tell that just by looking at the name of the triangle. All right, so what we're going to look at now is triangle ADC and BCD, and we're given that AD is congruent to BC, and we need to figure out what else we would need to say that triangle ADC and BCD are congruent. Well, DC is part of both of these triangles, okay? So I'm just going to trace over that side and say we know that DC is the same on both of these. So now we have a side, and then this other side that's congruent. So there's 2 different things we could ask for. We could ask for this angle to be the same as this angle, and so that would be angle BCD to be congruent to angle ADC, and that would then be congruent by side, angle, side, because there would be a side, an angle, and then a side, and then the same side, angle, and side. Okay? Or, since we have 2 sides, we could just ask for that 3rd side to be congruent and use side, side, side congruence. Okay, so they're congruent by that. And so that would be side AC would need to be congruent to side BD. So either one of these could be true, and then those 2 triangles would be congruent. Now we're given this information that RSG, so this angle, and RSH are congruent. Okay? And SG is congruent to SH. And it says from that information, can we say that triangle RSG and RSH are the same, are congruent triangles? And the answer to that is yes, because RS, this side right here, is a part of both triangles. So now we have a side, an angle, and then a side, and then the same side length, the same angle, and the same side length. And so we can say that these 2 triangles are congruent by side angle side congruence. Okay, again, we're going to look at this, and it says, what other information do we need to prove these two triangles are congruent, DWO and DWG? Well, there's two sides marked, OW and WG, that are congruent. And then we also have DW that's a part of both of those. So we could ask for this side here, DO and DG, to be congruent. So we could say we need DO to be congruent to DG. And then that would be side, side, side congruence. Or, again, there's another way. We could ask for angle DWG to be congruent to angle DWO. And that then would make those side angle side and side angle side. So that would be side angle side congruence. So again, there's two different ways or two different things we could ask for, which would let us prove congruence of those two triangles. Okay, so now we're going to look at these and say which ones can we prove are congruent, okay? And we have to use our prior knowledge here as well. So I'm going to look and I say, oh, okay, we have these two sides that are labeled that are the same. So two sets of sides that are the same. And then I also look here and notice that these are vertical angles right here, okay? So APB and XPY are vertical angles. So now I have a side, an angle formed by these two sides. So side angle side and side angle side. And so these two triangles, triangle APB is congruent to triangle XPY by side angle side. Okay, I can then look at this next one and say, oh, I have GHI and PQR, and I see there's an angle and then the next side labeled, and then that same angle, and side. So I know these two triangles are congruent. Triangle PQR by side angles, or I'm sorry, angle side congruence, because it's an angle, and then the next side. Okay, we're looking here and I'm like, okay, I see nothing is labeled right now, but I do see these two parallel line markings, and so I can say, all right, well, I see that this right here then would be alternate interior to this angle, and I see that PA is a part of both triangles. There's nothing else here that I can figure out, because this isn't an angle I can label because it's not part of the parallel lines, and I don't know anything about those angles or sides. So this one is not enough information to tell. I don't have enough information to use any of those theorems or postulates. Okay, well, I'm going to look at this one here and say that well, I see an angle that are the same. I see angles that are same there, and then I see this side are the same. So this one is actually angle side again. And it's going to be triangle ABX is congruent to triangle ACX. And remember that the order does matter, and you need to have the corresponding parts. So I started with the angle with 1 mark, and then I went to the angle with 2 marks, and then to X, that is the angle that doesn't have markings. And so I can tell I'm going in the right order because they should be corresponding parts, like what we talked about yesterday when we write our congruence statements. Okay, now we're going to look at a proof. Okay, so we're going to use our proof writing skills and what we've just learned about how to tell triangles are congruent or not. And we are going to say, oh look, the first statement is given. Okay, oh look, the next statement is also given. Okay. Well, then it says Km is congruent to Km. Well, if I look up here, Km and Km are congruent, and I'm writing the same side is equal to itself. And so just like when we were writing the same thing equal to itself when we were talking about properties all the way back in chapter 1, That's called the reflexive property. Okay, and so that's going to be our reason there. And then I can see, oh, side, a side, and a side, and the same sides over here. And so I can say these two triangles are congruent by side, side, side congruence. Okay. Next, we're going to do another proof. Okay, so we're given some other information here, and I'm going to say, okay, I see this is a given again. And then QR bisects, oh, look, our givens are separated. That is okay. Which means I'm going to have to figure out the reason here. So it says Q is equal to T, or sorry, angle Q is equal to angle T, and angle X is equal to angle R. Oh, well, I think that goes back up here to this one. X, Q, and TR are parallel. So Q and T are alternate interior angles, and X and R are alternate interior angles. So the reason here would be that they are alternate interior angles. Okay, so we have to go all the way back, and we're going to keep using that prior knowledge. Okay, and then it says QR bisects QT. Okay, well, what does bisect mean? It means it cuts QT in half. So that means that this part of QT and this part of QT are the same because Q or XR bisects those. Okay, so then that gives us our next piece. QM is equal to TM, and that's because of the definition of bisect. We know those are cut in half. Okay, now we need to look and see what congruence these triangles have. And we know that it's going to be congruent because that's the last statement in our proof, but it's going to be angle, angle, and then the next side, okay? Because it can't skip over an angle and a side. It has to be an angle, and then the next side. And so this one is going to be angle, angle, side congruence, okay? I'm going to put up some examples here. And what I would like you to do is to decide whether you can prove, and then also which congruence they would have if possible. Okay, so I should actually make this a little smaller, which I can do real quick so I can put them all up at the same time. And now I'm going to say pause. Pause your video, because I'm going to write the answers up here and share them. So I'm going to give you 10 seconds. So if you want it longer than that, which you should, pause your video and try these. Okay, here we are back with our answers. And so this first one is side, angle, side, because it's two sides and the angle in between them that are the same. This one, although we know all of the angles, that's not enough information because angle, angle, angle is not a way to prove congruence. This one here, part D, is going to be angle, angle, and then the next side. So it's angle, angle, sides congruence. Part E here, we have all three sides labeled that are congruent on both, and so that's side, side, side. Part F here, we have a side, an angle, and then the side that forms that angle. So these two sides are congruent, so that's side, angle, side. This one is also side, angle, side. So we have a side and the angle in between them that are the same. This one here is angle, angle, side. So an angle, the next angle, and the next side. Angle, angle, side. And then this one is not enough information because we don't have angle, side, side congruence or side, side, angle congruence. That is not enough information. We would need another angle somewhere or another side. Okay, I'm going to give you one more opportunity to practice here. I would like you to look at these and decide whether there is what else you would need to know to prove using these different types of congruence. Okay, so pause, and I'm going to put the answers up in about 5 seconds. Okay, so these are the answers here. Feel free to email me if you have any questions. Your assignment will be posted, and that is triangle congruence today.